All right, we're going to continue our lesson on exponents. Change it up a little bit. We're going to call it the laws of exponents. So we've got a few different rules, basically just 3 of them. All right, just 3 different rules for exponents. The first one is how to multiply with exponents. So multiplication. All right. So just let me, let's use what they have. Sometimes I think this makes it more confusing for some students, but I'm going to put it on here anyway. All right, here's what we do. When you're multiplying, all these things, well, the division and the multiplication, all have to do with if you have the same base. Do you see the A and the A right there? Exactly the same. It means the same exact number. All right, so A is not one number here, and right here it's a different number. All right, so when you have the same base, this only works when the bases are the same. It's supposed to be an A. It looks kind of weird. Anyway, same base. Everybody got it? So the A is a base and the A is a base. Here's what you do. When you're multiplying 2 numbers together and they both have exponents, okay, and they have the same base, you keep the base exactly the way it was. So you just write one base, and then, this may be kind of weird because it does say multiplication, but what do you think you do? You've done this before. You add the exponents. That's right. So it's m plus n. Right, make that look like an N. It still doesn't look like an N. There we go. Close enough. All right, so that's what we do. I want to show you why. All right. I mean, I could just say, okay, this is the rule. This is how we do it. I want to show you why we do it. So, for instance, if I had x, what if I had x to the 3rd times x to the 2nd? Everybody see that? I could just show you the rule, which I've done. I've shown you the rule right here. But let me show you why it's true. Because x cubed means what? I'll just tell you. X times x times x. Isn't that the same thing as x cubed? Yeah, we talked about that yesterday. That was what we talked about yesterday. Now it's being multiplied by x squared. So I'm going to multiply it by another what? X times x. So this right here is my x cubed. This right here is my what? X squared. So if I multiply them all together, how many x's do I have? Let's count them up. 1, 2, 3, 4, 5. No, I got 5. All right, so this is x to the what? 5th power. So even though it's a multiplication problem, you don't multiply the exponents. What do you do to the exponents? You add the exponents. Everybody good? Okay. So that's the reason why we do that. That's the reason why we add the exponents together. All right. I have the power rule second, but I'm going to write division right now. All right. So we'll write number 2, division. And again, this only works when you have the same base. Tell you what, let's pop back up here again. What if you had this? What if I had x to the 3rd times y to the 2nd? Do what normally? What would you do? And what would that be? It would just be this. Exactly right. Okay, that's what I was trying to get you to say. It would be exactly what we have right now. Okay. So you can't do these. Why can't you multiply those together? They don't have the same base. That has an x, that has a y. I cannot use this rule because they don't have the same base. I can only use this rule when I have the same base. Everybody good? All right. I know I'm repeating myself a lot, but I think that's what we need to do. Let's do division. Again, we can only do this with the same base. I'm going to do it like they did again with the A and the m. So I got a to the m. Now, again, we don't do this. Don't write that down. We don't do this for division. Very rarely. There might be one time where we do that, but not right now, okay? So we don't do that for division. How do we show division when we get into algebra? We write it as a fraction. That's right. That means division. This means a to the m power over divided by a to the n power. You with me? All right. So if multiplication, when you have the same base and you're multiplying, what do you do to the exponents for multiplication? You add them up. What do you think you might do with division? Exactly right. So how would I write this? I'd keep the base the same, and what do I do with the m and the n? Subtract them. So that's the rule for division. So when you have on the top and the bottom, and they're the same base, remember the a and the a have to be the same. If this was a b for a base, or a c or a d, I couldn't do this. I can only do it when the bases are the same. And then I would just subtract the exponents. Let's do a quick little example with that and show you why. Again, this is just to show you why. What if I had x to the, 7th divided by x to the 3rd? Now you might be able to do that in your head. Should be able to. But I'm going to show you why it works. X to the 7th. 1, 2, 3, 4, 5, 6, 7. There's 7 x's. That is x to the 7th. Agreed? Because it's x times itself 7 times, right? And then x to the 3rd is what? X times x times x. Everybody good? Now in fractions, one of your favorite things to do on fractions is to do what? Cancel out. Don't you like doing that? Yeah, I always like doing that with fractions, to cancel out. So look, I got 3 x's down here. 3 of these x's are going to cancel with what? 3 of the x's up here. How many are you left with? 1, 2, 3, what? 4. So what's my answer? X to the 4th. Now, that would be super crazy if I had this. What if I had x to the 57th divided by x to the 32nd? Am I going to sit there and write x to the 57th like x 57 times and then the x on the bottom 32 times and then cancel them out? Of course not. That would be ridiculous. So we're not going to do this all the time. It's just to show you why the rule works. Make sense? All right, so what about this? What would you do here? You keep the base the same, and what would you do with the exponents? You subtract them. So you just go what? 57 minus 32, which is what? 25? So that would be x to the 25th power. It's the same thing right here. X to the 7th divided by x to the 3rd is what? X to the 4th. What did I do to that 7 and that 3? I subtracted to get that. It's pretty easy, isn't it? Yeah. Yeah, for some of you guys, you already got this stuff down, no big deal. But some, you need the extra little push, all right? Let's do the 3rd rule. I said we're going to do 3 of them. Here's the 3rd one. I think that's all we're going to do. Hold on, let me just double check. Yep. Yep. All right. This is called the power rule. We just did this in my Algebra 2 class, had a test on it, had a bunch of problems where you had to apply the power rule. It's a power rule because a lot of times the exponents we call powers, right? We could say x to the 5th what? Power, okay? That's why we call it the power rule. So here's what the power rule says. We'll use that a, m, and n again, right? What if I had a to the m, I had it in parentheses, and it was being taken to another power. It was being taken to the nth power. This is not just a regular multiplication problem, is it? You're taking an exponent to another exponent. Does that make sense? All right, one exponent to another exponent. Here's the rule. The rule says you just keep the base the same. Anybody remember what you do to those m and n? You multiply them together. So you could go m times n. So there's your rule right there. Let's apply it. What if I had x to the 3rd to the 4th? Okay. I want to show you why first. Okay, it's going to be x to the 12th, yes, because you multiply the exponents together. But I want to show you why, because that means, what does this mean right here? It means we have x to the third multiplied by itself 4 times. So that means I have x to the third, another one, and another one. Everybody see that? It means you have this thing right here times itself 4 times. And there you go, 1, 2, 3, 4 of them. Now, what's the rule when you have multiplication? You add up all the exponents, okay? 3 plus 3 is 6, plus 3 is 9, plus 3 is 12. So this is x to the what? But instead of doing that, right, again, what if I had something like this? What if I had x to the 21st to the 17th power? Should have picked easier numbers. What if I had that? Am I going to write x to the 21st 17 times? No, that'd be ridiculous. We just have to know what the rule is. What does the rule say we do? We multiply these together. Let's make that to the 20th power, make it a little bit easier. So that would be x to the what? What's 2 times 17? 34. Stick a 0 on the end. 340. Okay? But that would be ridiculous to write x to the 20th 17 times and then add up all the 20s, right? So you just multiply 20 times 17 and you get that same thing there. It's coming back to you? All right. Let's do a few examples then. We talked about negative exponents, didn't we? Flipping it, top and bottom. Okay. So, what's that? Yeah. All right, let's do a few examples. This is example 9. They got a A, B, C, D, E to these examples. All right. And I'm going to give you a chance to try them yourself. I'll give you maybe 20, 30 seconds, okay, to do each of these. So write it down. Everybody should be writing this down. Then after I finish, I'll give you 30 seconds to work on it. It shouldn't take you that long. Should take you probably 3 seconds. But I'll give you a little bit. So it's x to the negative third times x to the fifth. So it's multiplication, right? So what do you do when you're multiplying with the same base? Keep this base the same, and then what do you do with the exponents? Add them up. What's negative 3 plus 5? It's positive 2. Boom, you're done. Easy as that. Agreed? Yeah. If you know how to add, it's easy. Let's do another one. X to the negative third to the second. Write it down, come up with an answer. I want you to write it down. You're not writing it down. You're not, what's that? You don't have a pencil? Okay. Yeah, I asked everybody to write it down. Even if you can do it in your head, I want you to write it down. All right, let's do it. This is the power rule, right? When you have an exponent taken to another power. So I keep the base the same. What do I do with these exponents? What does the power rule tell me to do with those? Multiply them together. And what is negative 3 times 2? Negative 6. You just leave it like that. What if they told you you had to make all your exponents positive? Let's see, do I do that in here? So what would I do if they said make all your exponents positive? Flip it, right? So remember, this is always over 1, isn't it? So I flip it to the bottom, and then I change the sign of the exponent. If I flip it to the bottom, what happens to that negative 6? It becomes a positive 6. What do I have left on top then? I have a 1 left on top, all right? Because it's always 1 times this. See those 1s? They're usually invisible, aren't they? Usually you don't really put them there. But I just put them there so you know that you do have a bottom to this, right? You have a denominator. So you take this, you flip it to the bottom, and then what's left on top? That goes away. That's down here on the bottom. 1 times x to the 6 is x to the 6. You got a 1 on top. Boom. That's the way you want to write it, okay? Let's do another one. 2x. That's in parentheses. Everybody write this down. So everything is being cubed. Everything in here. Well, what's inside of there? A 2 and a what? And an x. So everything's being cubed. So cube the 2 and cube the x. Let's see what you get. And simplify it, okay? Make sure it's as simplified as possible. If you have to multiply something together, do it. We good? All right, what'd you get? Timmy, what'd you get? Tristan, help him out. You didn't simplify it. You got to simplify it. Yeah, 8x cubed. That's the best way to say it. 8x cubed. Why? Because you're cubing everything in here. Watch. You're taking 2 to the third, was what you said, which is not wrong. But then you got to take what else to the third? You also got to take the x to the third. So everything that's inside that parentheses has to be taken to the third power. But that's not simplified. What is 2 cubed? You should be able to do that. I'm not going to give you some crazy number where you're going to get in the thousands, okay? There are going to be numbers that you can deal with fairly easily. So what is 2 cubed? 2 times 2 is 4, times another 2 is 8. So that's 8, and then what? X cubed. That's the best way. It's not the best way. It's the way. It's the only way that I want you to write the answer is right there. Okay? Let's do a couple more. Let's start up here. Part D. Let me see. All right. Now we're really going to test you. It's kind of like what we just did, but now they threw in a little fraction. As soon as people see fractions, they start freaking out. Like, oh, fractions. It's not that bad. Now remember, all the stuff in the parentheses has to be taken to the fourth power, right? So you just take the top to the fourth, and you take the bottom to the fourth. And then you just work out those numbers. Numbers are a little bit bigger than what we just did, but it's not too bad. You should be able to do that. So everything inside of here has to be taken to the fourth power. So let's do the top first. You got a 2 there, don't you? So it's 2 to the what? Fourth power. What about the bottom? What's that going to give you? 3 to the fourth power. Good. And now you got to simplify it. Don't leave it like that. Okay, simplify it. The numbers aren't that big. 2 to the fourth. Let's go through it. Ready? Everybody look up here. Watch my fingers. We'll do it 4 times. 2 times 2 is 4 times 2 is 8 times 2 is 16. So what's 2 to the fourth? 16. All right. Now this one might be a little trickier, but let me show you a little trick. Okay? There's 4 3s, right? So watch. 3 times 3 is 9. This 3 times 3 is 9. 9 times 9 is 81. You see that? So that's 81. Does anything cancel? Does anything go evenly into 16 and 81? No, it doesn't. So that is your answer. That's all you can do with that. We good? All right. Now, for the granddaddy of them all, at least this kind. And I'll give you a second to work on this. All right. There it is right there. You got to simplify this. All these problems say simplify. I got negative exponents. Do we want to work with negative exponents? So you could approach this a couple different ways. Oh. You could approach this a couple different ways. You could make them all positive exponents, but there's a rule for that, right? You got to know what to do. So if I don't want an x to the negative second, how do I make it a positive exponent? Flip it to the bottom, right? So if I flip it to the bottom, it's going to be x to the second on the bottom. But that x to the negative fifth, I don't want that as a negative exponent either. What am I going to do with that? Flip it to the top. and then change it from a negative exponent to a positive exponent. To me, I think that might be the easiest way to do this problem, okay? And I think it would be for you as well. So let's do it that way. I'll show you another way to do it, but I think we'll start off with the easiest way, the one that makes more sense to me. So I'm going to take this, flip it to the bottom. What's that become on the bottom then? X to the positive second. Then I'm going to take that x to the negative fifth, flip it to the top. What is that going to become? X to the positive fifth. That's way better than that, wouldn't you agree? Yep. And now we can apply that division rule. What does the division rule tell us to do? Subtract the exponents, okay? So I got 5 x's on the top, I got 2 on the bottom. 5 minus 2 is 3, so it's x to the third power. Here's another way that I like, give me just a second. Here's another way I like to look at it. X to the fifth means there's 5 x's on the top, correct? X to the second means there's what? 2 x's on the bottom. So 2 of these x's cancels with how many? 2 of these. How many are left over? 3. That's how my mind works when I think of this, okay, when they're all positive exponents. Does that make any sense? Okay, or I could have just subtracted. 5 minus 2 is 3. Same thing. Timmy?
No, that's right. Well, like, what makes it a wrong answer to subtract -2 and -5?
It doesn't make it a wrong answer. You're probably just subtracting incorrectly. But let's do it that way, all right? So let's go directly, use that division rule right now, okay, instead of changing them to positive exponents. I think changing them to positive exponents is the best way to do it. Yeah, because it's just a lot easier, right? We're much more used to the positive numbers. But you could still do it this way. What does the division rule say to do? It says to keep the base the same and do what to the exponents? Subtract. So what do I have? I got -2 minus what? -5. That's where people would go wrong. That's why I didn't show you that first, because I think a lot of people are going to mess that up. You know what a lot of people are going to do? They're going to say -2 minus 5. And that's probably what you were doing at first when you asked that question, is my guess. Is that true or not? Probably. Yep. So it's minus a -5. What happens here when you got 2 minuses next to each other? It becomes a plus. Now, what's -2 plus 5? It's +3, so it's x to the third. Okay? This might be more less steps, but I think it's more confusing for a lot of people. Not for everybody. Some people would rather do it this way. All right? But for a lot of people, I think they might mess up more here than doing this. What do you think? Do you like just flipping them, making them positive, and then just subtracting the positive numbers? You'd rather do it like this? And that's fine. There's no right or wrong. It's just whatever your preference is. Whatever makes you get the problem right, use that way, okay? So if you would rather just subtract the exponents right off the bat, then that's fine. There are situations where I like this way, because there are going to be times, maybe in the next lesson, let me see, or the next section. Yeah, it is. So let's do another example, okay? Same kind of stuff, but a little bit more, right? We're pushing it just a little bit. So let's do example 10. Example 10. We got an A and a B on this one. So here we go. X to the fifth, y to the -2nd, over x cubed y. All right, we need to simplify. That's what it says to do with these things. Now we're doing a couple different things, right? We don't just have one set of bases. Now we got 2. I got x's and y's. We didn't have that earlier. So I'll give you a few seconds to work on that. Wasn't me. Everybody good? Did you get an answer? A couple ways you could approach this. Now, I want you to write your answer, if you haven't already. I don't know if you did or not, but I want you to write your answer with no negative exponents. Did you do that? So write it with all positive exponents. So you may have done just subtraction, but you're going to have a negative exponent. So change it so that you just have positive exponents. Now the first one's pretty easy, this first part of this. It's the x's, right? So you got the same base, so what do? They're both positive, so you just take the base and subtract the exponents. 5 minus 3 is 2. Easy. Now, depends on how you like doing these, but you could take this y to the negative second and throw it to the bottom, all right? Or, by the way, what's the exponent for this y down here on the bottom? It's a 1, right? Or you could just subtract the exponents. Whatever way you like doing it, all right? Let's just subtract the exponents on this one. So y to the negative second over y to the first. So what do? Keep the y the same, subtract the exponents. Negative 2 minus 1. What is negative 2 minus 1? It's negative 3. Okay? But this is a negative exponent. I want you to write it so that there's no negative exponents, all positive exponents. So what would you do? Well, you take this and you flip it to the bottom. You're like, well, there is no bottom. There's no denominator for this. Well, yeah, there is. What is it? It's a 1, right? So you take this, you flip it to the bottom, and you make it y to the what? Positive third. So you could do it that way. That's perfectly fine. And that's your answer. It's completely simplified, and all our exponents are positive. Or you could do it another way. You could have done this. Here, I'll do this in another color. You could have taken this and chucked that to the bottom right away. Whoops. Did anybody try it that way? If it was me, that's what I would do. Doesn't mean it's the right way, all right? Some of you guys would just rather subtract the exponents. Perfectly fine, okay? But this is what I would do. And then, what do you have on the bottom? Just a y cubed. Boom, there it is right there. See how easy that was? It's how you think about it, right? It's, again, like I said, there's no right or wrong way. It's just a slight variation, that's all. All right, let's do this one. Now, this is really going to test everything that we've talked about yesterday and today. So if you can do this, then probably good. I'll give you half a minute. Again, I want you to simplify it, and I want all the exponents to be positive. You could approach this all kinds of different ways. I'll show you how I would like to do it in about 5 seconds. Anybody got an answer yet? I'll give you another 30. Go. Kalia, did you get anything? How did you approach this? So you put this to the bottom and you put this to the top? Okay. So that's exactly what I would have done. So watch. The 3, keep the fraction. That 3 is just a 3 of the first, so just keep that on the bottom. Okay, you're not going to switch that. But I'm going to take this x to the negative third, throw that to the bottom. So what's that become if I chuck that to the bottom? If I flip it, I got to change the sign, right, of it. So it was negative, I make it positive. This y to the negative first, That was on the bottom. Where am I going to put that? On the top. And I'm going to make that y to the positive first. You don't really need that 1 there, but I'll put it there anyway. You see that? We're not finished, though. So that's what I would do first, okay? I would do the stuff, remember, order of operations, do what's in the parentheses first. So that's what I would do. I simplified in the parentheses. Now, when I have stuff in parentheses, when I have a fraction and it's being taken to a negative exponent, this is one of the last things we talked about yesterday, I think. Do you remember what we do with that fraction? I'm going to flip the fraction, and then I'm going to change that to a positive 2. All right, so here we go. Let's flip this fraction. So this 3x cubed is going to go to the top. And I don't have to change the signs of these things because I'm changing the sign of the exponent right here. Okay? So all I'm doing is just taking the stuff on the bottom, putting it on top, taking the stuff on the top, and putting it to the bottom. And then this is going to be to what power? To the positive second power, correct. And now we just simplify it. At least we've taken care of all our negative exponents. So we don't have any more negative exponents. But now we have to do what we did earlier today. Take everything and square it. So what do I square? Well, take the 3 and I'm going to square it. Take this x cubed and I'm going to square it. What do I get? Let's actually, I tell you what, that 3 squared, we can do that in our head, can't we? What's this? 3 squared is what? 3 squared, come on, talk to me. 9, thank you. 3 squared is 9, and then x cubed squared. This is a power rule. It's an exponent to another power. So what do I do with those? Multiply them together. 3 times 2 is 6 over. What's my exponent to that y? You said it earlier. It's a 1. So now I take the y to the second. So y to the first to the second is just y to the second. And then that is all you can do. Can I cancel out this 2 with that 6? No, because they're different bases, right? That's an x to the 6. This is a y to the second. I can't do that. I just leave it like that. And that's the nicest, prettiest, simplest form that I could put that in. All right, I don't have any negative exponents. I took that 3 and I squared it and I got a 9 out of it. And then that looks nice and pretty. And there you go. You good with that? When's this over? 15? Okay. We got a few minutes. We got just a little bit left to do. Did everybody get that down before I move it out of the way? Okay. See how that took almost everything that we talked about yesterday and today and put it all into one problem, didn't it? All right. So if you can get this, you should feel pretty good about knowing the stuff we've been going over. All right. Let's talk about the inverse of squaring something. Any ideas? So if I said, what's the opposite of squaring something? What would that be? Yeah, it's that thing. Square root, that's right. The inverse of squaring is taking the square root of something. So watch this. What if I had 4 squared? What is that? 16, right? So here's what I want to do. I want to do the opposite. I want to go from here to here, okay? So if I take the square root of 16, the opposite of squaring something, what am I going to be left with? The 4, all right? And what's the symbol for square root? It looks like this. You've seen that a million times, haven't you? Maybe not a million, but you've seen it a lot. So that's the symbol for square root. What does that mean? It means what number times itself, right? That's what squaring something means, okay? What number times itself is going to be 16? I've had people say 8 times 2. But are those two numbers the same? No. What 2 of the same exact numbers multiply together to give you 16? 4. Exactly right. See how it's the opposite of squaring something? Yeah. Let's go through some numbers that we should know. What if I asked you to square to 36? You should be able to do this in your head. It's 6, because what number times itself? The same two numbers have to multiply to be 36. 9 times 4 is 36, but are they the same two numbers? No. 18 times 2 is 36, but are they the same two numbers? No. What same two numbers multiply to be 36? 6. So the square root of 36 is 6. What's the square root of 100? It's 10, because 10 times 10 is 100. It's very helpful to know your multiplication tables when you do square roots. What if I had something like this? Square root of 17. Right, this does not come out even. All right, it doesn't come out to a nice whole number. Because there is no, in my multiplication tables, there's no number times itself that's going to equal 17. All right, now this number does exist. You could put it in your calculator. Here, let me pull out my calculator right here on the screen. I don't think this shows up on whatchamacallit, on the YouTube video. So sorry if anybody's watching the YouTube video. But here's how we do it. Watch, square root of 17. There's a square root button right there. I know it's kind of small on the screen, but watch, I hit second, I hit square root. See the square root button? Then I've hit 17, and then close the parentheses, hit enter, boom. It's that big crazy decimal, 4 point something. That should make a little more sense, because what is the square root of 16? It's 4. What's the square root of 25? It's 5. Where is 17? It's in between, isn't it? And it's a lot closer to 16 than it is to 25. So look at that decimal. It's just a little bit more than 4. Does that make sense? So if I put in like the square root of 23, what do you think that is? 4 point something, a little bit bigger than this, right? Let's just do that for fun. All right, so we put square root of 23, 2, 3. And then, I don't know, let's take a wild guess. What do you think? It's pretty close to 25. 4.8 probably, somewhere around in that. Yep, pretty close. 4.795, that's pretty close to 4.8. So, yep. You understand what these are doing now? I mean, you can always take the square root of any number. Well, except for one. Well, except for, you can't take the square root of a negative number. Let's talk about that for a second. Did we talk about that earlier? Yeah, let's talk about it again. So the square root of negative 9. You would think it would be like negative 3, wouldn't you? At first glance. But remember, the two numbers have to be the same. Is negative 3 times negative 3 negative 9? No, it's positive 9, isn't it? So are there any two numbers that multiply together to give you negative anything? Of the same two numbers, I should say. No, there's nothing. So you cannot take the square root of a negative number. Now later on, if we get that far, we're going to actually talk about taking the square root of a negative number. And it sounds like I'm lying to you when I say you can't take the square root. But for all the real numbers, this does not exist, okay? There is no real number that you can take the square root of. If it's, I didn't say that right. There's no real number, negative number that I can take the square root of. That's what I should have said, okay? There is a thing called an imaginary number. We won't worry about that for right now. All right. What about 0? Can you take the square root of 0? Is there a number times itself that equals 0? 0, right. 0 times 0 is 0, isn't it? So sure, you can take the square root of that. Very good. What if I did this? What if I said the square root? Timmy, don't throw things in my room. I can see what you're doing. You waited till I looked down and then you threw it.
I was throwing it in the trash can.
Huh? It's throwing things in my room. It doesn't matter if it went in the trash can or not. All right, don't throw it. It's not that hard. So watch. What if I had this? Everybody look up here. Come on, we're almost done. What if I had this? Well, what's 7 squared? 49. What is the square root of 49? It's 7. But look what happens. Do you see the square and the square root? They basically just go away, don't they? You see that? Right? They kind of cancel each other out. Right? So that square root cancels out that square, and what are you left with? 7. So check this out. That means we could do something like this. What if I had 341 squared? What if I had the square root of 341 squared? What's the answer to that? Without using a calculator. Without even doing any math in your head. What is that? It's 341. Exactly right. So we have a little rule that says this. The square root of x squared is equal to what? Come on, we're almost done. X, that's right. Okay? And that's all there is to that. All right. Did I not write the... For some reason... I didn't write that on there. All right, so you do have some homework. It's we're calling it R2C, so it's section. Now I know we taught R2E, but this is homework, okay? So it's R2C. It's our third homework over this. And hold on, it's page 27, and it's 73 to 93. But you're only doing the odds. All year, we're only going to do the odds because I don't have a teacher's edition to this book. So we'll just do the odds. There it is. That's your homework. Have that finished for tomorrow, please.